Three values. Three values. Two values. We're getting there. Good. Double check those last two. Check your settings. Same for you. Last two, check your settings.
That's a good question.
Do you see a degree symbol? On that input, do you see a degree symbol anywhere in there?
No.
No.
Is it reading?
Yeah.
Oh, that's why. Yeah, that's why you did it. That's why you didn't get it.
Good. Very good. That's perfect. Very good. Sorry, excuse me. Oh, so first let's double check. You're still in degrees,
Oh.
so you need to go mode. Oh, you don't.
Oh, radians.
Radians. And then to get the pi, notice he's in blue right above that little arrow button. So second and then the arrow button. Okay, so I need some answers. They start picking on people. Natalia, what did you get for sine of 60? 0.866. Can I get a thumbs up if you also got that? I see thumbs up around the room. Very good. Perfect. Next one. What did we get, Paul? 0.5. Can I get thumbs up if you also got 0.5? I'm getting some thumbs up. So what's the difference between 2 and 3? Radians, yeah. If you don't explicitly see that little circle for degrees, it's in radians. If you see a pi floating around, that's a dead giveaway that it's radians. And there is pi on your calculator. To get pi, you press the second button, if I knew how to spell, which apparently I don't today. And then the little button that has the caret above it. And that should give you a pi. Not the yummy kind, but the math kind. All right, last one. LD, what'd you get? 0.866. Did anybody else get that? I see some thumbs up. Very good. And we know we should, because if I scroll back up here, pi over 3 and 60 are giving us the same answer, because in the graph, pi over 3 and 60 are the same angle in the picture. So they should give us the same answer. And I will bet you money that square root of 3 divided by 2 is 0.866. And that's where that's coming from. Yay. Okay. Last thing from our notes from last time, focusing on sine and cosine. A reminder that domain is the number we're plugging into the function. So that's what's allowed to go inside these sines and cosines. And range is what comes out. The range is the possible answers. Sine and cosine take all real numbers as their domain. But they don't output all real numbers. Ooh. In evaluating, did we ever get a number bigger than 1? No. If we look at the unit circle and we look at those x and y values, the numbers in parentheses that are sine and cosine, what's the biggest number that you see in those parentheses? 1. Yeah. And on the other side, if we flipped it, would be -1. The output for these guys is always a number between -1 and +1. Inclusive, square brackets. As we saw, it could be equal to 1. So we have to use square brackets. Next week, we're going to talk about the graphs of these functions by themselves, separated from the unit circle. And both sine and cosine go back and forth and back and forth and back and forth, up and down, between 1 and -1 forever and ever. If you've taken physics and you've talked about circular motion or pendulum motion, you may have seen that graph before. Whew. Okay. Questions? Concerns? Is anybody still awake today? Okay. Then what we're going to do, now that we know about how sine and cosine work, is we're going to talk about the other 4 trig functions. That's our goal today. What are they? How do we define them? How do they work? Yeah. So on that blank sheet of paper, that's not the pre-printed packet, we're starting 5.3, the other trig functions. And we make them sound like redheaded stepchildren when we say it that way, but they are not in fact redheaded stepchildren. We love the other trig functions. The reason they're grouped in the other category is all of the trig functions we're introducing today are combinations of sine and cosine. So sine and cosine are the primary trig functions. All of the other trig functions depend on them. And there are 6 trig functions total. We already know sine and cosine. Yes. Those I'm not going to test you on. If you're curious what they look like, they're in Canvas, but we're not going to do them in class together. And when you learn SOHCAHTOA, we know the SO was for sine, the CA was for cos. What's the TOA for? Tangent, yeah. So the next one is tangent. And we write tangent as tan for short. And tangent is equal to the sine of that angle divided by the cos of that angle. So tangent is the ratio of sine to cos. Yeah. There's a limitation here because this is a fraction. What value am I not allowed to divide by? 0, yeah. So this doesn't work for angles that make cosine of t 0. That's a no-no. It tells me when I look at the graph of tangent, I'm either going to have asymptotes or holes. There are places where the graph can't exist. Yeah, good. Okay, the next 3 are the reciprocals of these 3. What does it mean to be a reciprocal? Yeah, flip it. Take a fraction, flip it upside down. So our next one, we're going to start with secant. Secant, yes. You can thank the Greeks for their weird naming of things. Pythagoras and his little weird group of people had a lot of say in what's going on here. So we get weird names, I'm sorry. And we use SEC for secant. That's nice, that makes sense. And then I'm about to do something that makes a little less sense. Secant is the reciprocal of cosine. Which should make you unhappy because it would make a lot more sense if secant were the reciprocal of sine, because then you'd have s with s, but no. They like to torture us. So secant is 1 over cosine, and because cosine's in the denominator, same rule. Cosine can't be 0. Is there a secant button on your calculator? Alexis is shaking his head no. So if you are asked to evaluate secant, you actually plug this into your calculator, 1 divided by the cosine. There is sine, cos, and tan on your calculator, but the last 3 there's not. You have to do the 1 over definition. Yeah. Okay, next one. Next one is called the cosecant. And you would think logically that would be the reciprocal of cosine, but no, it's the reciprocal of sine. And the short form for cosecant is CSC. I can't use COS because I already used that for cosine. Got to use something else for cosecant. So CSC. And this guy is 1 over sine. And we know our denominators can't be 0. So now we're limited by the fact that sine cannot be 0. This guy's also going to have holes or asymptotes, but they're going to be in different places than the other guys. Okay, I've got the reciprocal for cosine. I've got the reciprocal for sine. What am I missing? Tan. I'm missing the reciprocal for tangent. Yeah, that's the last one. Reciprocal for tangent. And that is called cotangent. That one actually kind of makes sense. Except I don't know how to spell today. And the short for cotangent is COT. Cot. And he is 1 over tangent. But we are not going to stop there, because tangent is also a fraction. Tangent is sine over cosine. I want to take sine over cosine and get its reciprocal. What would that be? Reciprocal means flip. What's on top if I flip it? I take the tangent function, I flip it. Cos, yeah. Yeah, no, that's right, Fanny. Bonnie, I can talk. I swear I can talk. It puts cos on the top and sine on the bottom. Words are hard. Yeah. Both those definitions are true. Both are valid. Sometimes the 1 over tangent's more helpful. If you're doing calculator math for cotangent, that's the faster way to evaluate, because then it's just 1 divide instead of cos of something divided. Sometimes this is more helpful. Both are correct, and you should get the same answer both ways. In this case, what am I not allowed to have in the bottom? 0. So it's not tangent that can't be 0, it's sine that can't be 0. Which feels a little weird, but it makes sense, because if I look at the tangent fraction, if I go back up here, that fraction is 0 when the top is 0, and the top is 0 when sine is 0. So this guy is 0 when this guy is 0. So I don't care about cos, I only care about sine for that guy. So all we're going to do for the rest of class is practice using those definitions to help us find the trig function values from a point on the unit circle. Yeah, that's it. That's all we're doing today. going to do 2. I think we have time to get through 2. Given point on the unit circle, find all 6 Trig's functions. So I'm going to give you the x and y coordinates of a point that's sitting on the outside edge of the unit circle. We're going to use that point to find the value for all 6 trig functions. So what did I do first? Nope. Wrong thing. So our first point, negative root 3 over 2, comma 1/2. I already have 2 of those 6 answers. Because when we were introduced to the unit circle on Tuesday, one of the first things we learned about it is the points on the unit circle are all cosine of the angle, comma, sine of the angle. So if I give you a point on the unit circle, I'm giving you the value for the cosine function and the sine function. So of those 6 things I'm asked to find, I just found 2. So I'm going to do these in order. So sine of our angle t is equal to 1/2, because sine is the y coordinate. And cosine of our angle t is negative root 3 over 2. And our job is to use those to find the other 4. And we're just going to go down that list of 6 that we created above. So after those 2, the next one we learned was tangent. I need to know what tan of t is. The question is, how do we calculate tangent? Sine over cos. Yeah, sine over cosine. And I know both those numbers. So I'm going to build a fraction. Sine is 1/2. Cos is, come on, pen, negative root 3 over 2. Fraction divided by a fraction. I know I can turn that into a multiplication problem to make it prettier. I put the numerator in front, and I multiply it by the reciprocal of the denominator. There you go. We're going to flip that. So 2 over root 3, and I just stick the numerator in front of, or the negative in front of the numerator just for consistency, because it doesn't matter which side of the fraction bar it sits on. The words are hard. It should be there somewhere, doesn't matter where it sits. Nope. And I see something that cancels. Yeah. 2's go away. Makes our answer prettier. On top, I'm left with a negative 1. On bottom, I'm left with a root 3. And if you stopped here, you would be mathematically correct. However, because this is college math, you will never see a mathematician leave it as negative 1 over root 3, because mathematicians do not like radicals in the denominator. I see that and it makes my skin crawl. So we need to rationalize the denominator. And that sounds scary, But it's really not, because all we're going to do is multiply top and bottom by whatever the bottom is. Bottom is root 3. Just going to multiply top and bottom by root 3. Here's why we did that. In the numerator, 1 times it's something is just the something back, so that's negative root 3. On the bottom, when I multiply something by itself, I'm squaring it. It could be square root of 9, but I'm going to write it another way. What do we know about squares and square roots? Cancel out, yeah. They're inverse operations. They're going to undo each other, which is just going to leave me with square root of 3 over 3. I'm going to go back and I'm going to circle the answer before we rationalized it, because at some point we know we want the reciprocal of tangent, and that guy's going to be the faster way to get it. Halfway done. 3 more. And they're all reciprocals. Just flipping fractions upside down, yeah? Scoochie this up a little bit. Okay, what came after tangent? Secant. Very good. SEC. SEC of our angle T. And I know secant is 1 over cos. And my cosine is negative root 3 over 2. Which just flips it. Reciprocals flip. This is going to be negative 2 over root 3. Am I done? Am I done, Emma? No, why am I not done? Very good. We shouldn't have square roots floating around the bottom. No square roots in the denominator. And you're right, it's exactly the same process as the red. I'm not going to write it out this time because the pattern is always the same. On bottom, the thing comes out from under the square root. On top, I pick up a square root. Top and bottom by root 3 gets rid of the root down here, pops a root on top. And we're going to do that a lot. You're going to see that pattern over and over until you're sick of seeing it. It'll get faster as you practice. Yeah? Yay. 2 more. We're getting faster. Next one. After secant is cosecant. CSC. Cosecant is the reciprocal of which function? 1 over sine. Very good. And we know sine is 1/2. What's the reciprocal of 1/2? If you flip 1/2 upside down, what happens? 2 over 1. Perfect. Which is just 2. Happy face. We like the ones that don't have roots in them. Are we ready? One more. Last one is cotangent. Cotangent is the reciprocal of tangent, which we already have. And I could use the answer that we boxed, negative root 3 over 3. But if I flip this fraction upside down, it puts a radical in the bottom, which I don't want. That's why I circled the unrationalized guy. If I take 1 over root 3 and flip it, the root goes to the top, which is not a problem. So my suggestion when you're doing the tan and cotan is pay attention to what your halfway answer is with tangent. Sometimes that one is the one that's easier to flip. So this is just 1 over negative 1 over root 3. And when we flip it, the root comes on top. Negative root 3 over 1, which is just root 3. Yeah, negative root 3. Happy face. I'm going to zoom out for a second. When you look at the sine and the cosine, there's 2's and root 3's floating around. All of our answers have 2's and root 3's floating around. So typically when you're calculating the additional trig functions, you're going to have those same numbers popping up in your answers. Also notice when cosine is in, nope, that's not what I wanted to do. Let's try that again. When cosine is negative, right, here was our initial negative. Look at the others that end up negative. Tangent ends up negative, secant ends up negative, cotangent ends up negative. Those 3 functions have cosines floating around inside their definition. This is sine over cos, there's a cosine in it. This is 1 over cos, there's a cosine in it. This is cos over sine, there's a cosine. The reciprocal of sine didn't pick up the negative, there's no cos in it. Okay, what I'm going to do is I'm going to pop another point on the board, and I'd like you to use the last few minutes of class to try this same process in your group. Do it now so that when you come in on Monday and we use it as a warm-up, it's not a total surprise. Yeah? I know. We're almost out, I promise. It's almost time to go home. So second point, same process, all 6 trig functions, is root 2 over 2, comma negative root 2 over 2. You'll notice the sine and cos have the same value, but just a minus sign different. That's going to make some of those calculations a lot prettier. Yeah? You got about 6 minutes in your small group. Make sure you bring this back with you on Monday, and we'll finish the process together.